Awesome. Thank you. Thanks. Thanks, Ron. And hey, folks, once again, apologies for a little bit of the mix up. I think we're live, we're on the way. We're here to talk about how we can get PG Parquet to work natively with YugabyteDB and Postgres. And I have Harsh with me joining me. So maybe, Harsh, why don't you do a quick 1 minute intro,
Yeah, thanks, Karthik. Hello, everyone. I am Harsh. I joined Yugabyte around 3 years back as a software engineer. I'm part of the growth and ecosystem team here. So for today's YFTT session, I will be talking about PG Parquet, which is an upcoming extension that we have added to YugabyteDB. Karthik, can we start with the session or?
Yeah, why don't we jump right in, Harsh? Why
Cool.
don't you tell us what is Parquet? What is all the hoopla about Parquet and so on? Yeah.
Yeah, cool. This is the agenda for today's session. I'll start with giving a brief introduction about Parquet files and PG Parquet. We'll talk about what are Parquet files and what the PG Parquet extension actually is. I'll also delve into the core architecture of the PG Parquet extension, and I'll also try to explain the top level view of how the PG Parquet extension works. At the end, we'll also have a demonstration to show you guys how we can use the PG Parquet extension with YugabyteDB. So Parquet files are a columnar storage file format, which is designed for efficient data storage and retrieval. It's widely used in big data systems and analytics because it's efficient for both querying and storage. This is a typical high-level representation of a Parquet file. So traditionally, in row-based formats, we have the data which is stored as rows or records. In Parquet format, these rows are first grouped into row groups, as we can see here. These are row groups, and within each row group, we have column chunks, one for each of the column in the data set. So a column chunk basically stores only the data of a single column inside a row group. These column chunks are further divided into data pages. A data page is the smallest storage unit of any Parquet file. Each data page has a header which stores the metadata information of that data page. It can store the data page offset and also the compression algorithm, encoding algorithm that is used. So any application that is reading a database, it can use this metadata to basically read and decode that page. Also in Parquet file, we have something which is called the footer metadata. It's basically the metadata of the entire file, which is stored at the end of the Parquet file. This metadata usually stores information like the number of rows in the entire data set and the schema of the whole data that we have. It also stores the metadata about each of the row groups. The number of values that we have in each row group, the compression algorithm used. It also stores the minimum and maximum values of each of the column chunks in each row group. So this actually helps in filtering out data. So if any application was traversing through a Parquet file, it will first read the footer metadata to basically limit their data scan to the row groups that they are interested in by using the filter that they have. So some of the key features in Parquet format are it is built for analytics. So it is a columnar based format instead of row based format. So it is highly efficient for aggregating and filtering. The Parquet format is really great for analytical queries, especially that want to query only specific columns instead of the entire data set. It is highly compressed and efficient. Since the data is stored in a column-wise format, we can have a different compression algorithm for each of the column, which best suits their data type. This actually reduces a lot of storage and network transfer cost, since the size of the file reduces a lot. Parquet files are self-describing and schema-aware. So all the information needed by any application to actually read a Parquet file, it's written inside the file itself as the metadata at the end. It is a widely adopted standard. So there are almost all the analytical engines such as BigQuery or other engines that we have. They support this Parquet format. This actually makes it perfect for data exchange. It is ideal for exporting data from any operational database to any analytical environment, since it enables direct sharing of data without any complex ETL pipelines. This is actually where the PG Parquet extension helps us, because it enables Yugabyte to directly read or write any Parquet file. Now let's talk a bit about what
So
actually.
and just so like I think just to ask you a couple of other things. So now with Iceberg and Open Table format, that's all based on top of Parquet. Is that right,
Right.
Hers?
Yeah, yeah, yeah.
So it's a big deal, right? Like right now with analytics and transaction data coming together to fuel AI applications, so on and so forth. It's actually a big thing now, right?
That's absolutely right. Yeah.
Makes sense. Thanks. Yeah, keep going. Let's see what PG Parquet is.
Yeah. In simple terms, PG Parquet is a PostgreSQL extension that allows you to read and write Parquet files via the copy to and copy from commands. Now, these Parquet files can be hosted on your local file system, and as well as any of the object stores that we have. It could be AWS S3 or GCS or Azure Blob Storage. In addition to copying data in and out of a Parquet file, it also supports few functions that we can use to explore existing Parquet file data. It would help us to inspect the schema and metadata of any Parquet file using the metadata that is stored within the Parquet file at the end. So PG Parquet, it's built in Rust. It uses the PGRX framework. It leverages Apache Arrow and Parquet Rust ecosystem for Parquet file operation. I'll be talking about the PGRX framework and Apache Arrow later also. So yeah, so PG Parquet has made it a lot simpler. It simply extends the Postgres copy to and copy from command. There is no other SQL required. So we just have to create the extension using the create extension command. So to if you want to export the data of any table to a Parquet file in your local file system, you can simply use this copy to syntax. So copy table to path to the Parquet file and with format Parquet. It's not necessary to specify the format Parquet. If you, it's necessary only if you are not using the .parquet extension for the file. So this particular command will simply create a .parquet file in your temp directory, and it will copy the row-based data of this table into the column format data of Parquet. Similarly, we can export and import data from a Parquet file which is hosted on any object store, for example, AWS S3. So here we have the commands to actually do that. Instead of just the local file path, you just have to provide the correct URI for PG Parquet to be able to access your Parquet file on your S3 bucket. So copy table to and the URI of your Parquet file. This would copy the row-based data in your table into the Parquet file on S3. And similarly, we can import the data from S3 bucket into your table. Now, there are also other configurations that PG Parquet provides. So if you remember, I told you about row groups, which are basically a few rows grouped together. So there is also a setting which you can use to specify the number of rows that you want in a particular row group. There is also another setting which you can use to specify the size of the Parquet file that gets generated. So similarly, you can specify the compression type that you want. So there are several configurations that you can use with the PG Parquet extension. Now, let's dive into the core architecture of PG Parquet. So as I mentioned, PG Parquet is built in Rust, and it makes use of the PGRX framework. So PGRX is a Rust framework for building PostgreSQL extensions. It provides bindings to Postgres internals, abstractions for SPIs, triggers, and GUCs. It also provides build tools which help us to actually package and test out these extensions which are written in Rust. Essentially, it allows developers to write extensions in Rust instead of C, while still producing a binary file which can be loaded into Postgres. We also have other Rust-based PG extensions which use the PGRX framework. For example, PG later, PGDD, PL Rust, and PGML. We do plan to add support for to some of these extensions. I think PGML is already work in progress. Now, yeah. So PG, as I said, PG Parquet leans on Apache Arrow and Apache Parquet Rust ecosystem for actually reading and writing the Parquet format. So Apache Arrow is basically an in-memory columnar data format, which is designed for fast data processing. It is ideal in-memory transport layer for data that is being read or written into a Parquet file. So essentially, PG Parquet uses this Apache Arrow format to actually convert Postgres row-based data to Parquet columnar data, and also the other way around. So any data, any tabular data which is to be written into a Parquet file would first be converted into the Arrow format, and then it would be written into the Parquet file. And similarly, any Parquet file data which is to be converted into a tabular data would be first read in memory as Apache Arrow format, and then it would be written into the table of your database. Next, I wanted to mention some of the major crates that are used by the PG Parquet extension. For those of you guys who don't know, so a crate in Rust is basically the fundamental compilation unit. It can be considered similar to a library or a jar that we have in Java. So the first important crate which gets used is the Arrow crate, which is basically the Rust implementation of Apache Arrow. PGParquet uses this Arrow to actually convert the tabular row-based format into the columnar Arrow format, and also also the other way around. There is also a lot of typecasting which is required to match the schema of the table and your Parquet file. The Arrow crate helps in that also. Another crate which gets used is the Parquet crate, which again is the Apache Parquet implementation in Rust. PG Parquet uses this crate to actually read and write Parquet files. Now, the third important crate which gets used is the object store crate. As the name suggests, it is used to access the Parquet files which are stored in any of the remote object stores. Now, I wanted to give you a top level explanation of how the copy to command works when we use the PG Parquet extension. So here I've listed the major operations that are involved in the execution, and also the key crates that are used in each step. So the step one is to simply intercept the copy to command. The copy to command is intercepted, and it is found out whether the format specified is Parquet or not. If the format specified is Parquet, the URI from that command is extracted, and we use this URI to set up the object store if the object store is getting used. The next step is to basically get a select query from the copy to command. This select query is needed to actually get the data which is to be written into a Parquet file. After we do that, the next step is to obtain the arrow schema from the Postgres table schema. So whatever table is being used, whose data is to be transferred to a Parquet file, we use the schema of that table to extract the arrow schema from that. So it is the number of columns that we have, the type of columns of each of the table. We typecast the types of each column into arrow format. Once that is done, the next step is simply to get the tuples that we receive from the select statement and convert them into record batches of the Apache Arrow format. Now, a record batch in Apache Arrow format is roughly equivalent to a row group in Parquet files. So once this conversion is done in memory into the record batches of Arrow format, the next step is to simply write those record batches as row group into Parquet. So now, one by one, all the tuples are converted into record batches, and they are written into the Parquet files. The last step is actually file finalization, which actually means to write that metadata at the end of the file. Now, PG Parquet basically gets this metadata when it is actually writing the row groups. So all the column stats that it needs, the minimum value, the maximum value of each of the columns, that is actually calculated when the data gets written itself. After all the data gets written, all the metadata is taken out and it's put into the file at the end. So this is how the process happens, and the data from a tabular format is converted into column format of Parquet. Similarly, let's see what steps are taken in a copy from command. The initial few steps are similar to copy to. We have the copy from command interception, figure out the URI, set up the object store. And in copy from also, we extract the arrow schema from the Postgres table schema, into which the parquet data is to be written. Now, once that is done, the next step, this is the major step in the copy from command, which is basically to match this arrow schema that we have obtained with the schema that is present in the footer metadata of the parquet file. So these two schema need to match for us to be able to move the parquet data into the table that we already have. They try to match the schema. If there is some mismatch in the column types, there is a typecasting that is attempted. But if that is also not possible, it will simply error out at this step and won't go forward. So once the schema has been finalized and the matching of the schema has been done, and if it is compatible with the table that we want to import the data in, the next step is to simply start reading the parquet file. So each of the row groups of the parquet file are read as a record batch in memory, and then the record batch are converted into the tuples of the table. Once all the record and row groups and record batches have been converted, the last step is to simply insert the tuples into the table, which is specified in the copy from command.
Yeah, that's pretty neat seeing the conversion from parquet to rows, right? Yeah, let's keep going. Let's keep going. Maybe you have a demo, right, to show us.
Yeah. I do have a demo.
Let's maybe
So I
go.
think
Yeah, yeah.
we're doing good on time. Sure. Cool. So yeah, one important thing is so for PG Parquet to be able to access any object store, it would definitely need the credentials to be able to access the Parquet files which are stored there. So PG Parquet mainly allows configuring object store credentials from environment variables. For example, we can use AWS credential environment variables to set up the credentials of your S3 bucket, or config files. Example, we can use the JSON config file for setting up GCS. These are the two important methods that they are used. There are other methods which are specific to, let's say, AWS or specific to Azure, but these two methods work predominantly for all the object stores that PG Parquet supports. So these credentials have to be configured on the database servers themselves. This actually creates a bit of a challenge for database cloud deployments like YugabyteDB Aeon. So to overcome this challenge, we are currently working on adding client-side credential configuration support. Once that is done, I think we won't have be having this challenge. We are also planning to support add this support to the upstream extension itself. In fact, I've already raised the PR and we are in conversation with the PG Parquet team. So we want this support to be added to the upstream extension itself so that other users can also make use of it. Now I think we are good. We can start. I have recorded a small demo to basically show you guys how we can use PG Parquet with Yugabyte. So I've already recorded the demo. In the demo, I'll be using a single node YugabyteDB cluster, which already has an employee table created. There are about 10,000 rows already inserted into the table. As part of the demo, I will try to upload this table data into a AWS S3 bucket. Then, as if you guys would remember, I told you guys that PG Parquet supports few functions to inspect the metadata and column stats. We would do that for the Parquet file that gets generated, and at the end, we'll also try to copy this data back into another empty table and see how it goes. So let me start the
Awesome.
demo.
Yeah, let's see.
Cool. I hope the terminal is clear and visible.
Yes, it is. Yes.
Cool. So yeah, as you can see, I already have a local single node cluster started. I'm connecting to the MySQL SS shell, and I'll show you the definition of the employee table that we have. Yeah, so we have about 6 columns in the table. ID, first name, last name, department, salary, hire date. Now I'm showing here the number of records that we have in the employee table. There are about 10,000 rows, as I mentioned. So yeah, this is the S3 bucket which I'll be using, which I'll be trying to upload the Parquet file into. So as you can see, currently we do not have any objects uploaded. Now I'll try to run the copy to command using the syntax that I showed you earlier in the slide.
So you're copying now from your machine to S3, right?
Exactly.
Yeah, got it. So copy
So
from your machine to S3, and the data in your machine is on a YugabyteDB table, Postgres Yugabyte format, and you're going to push it to S3 in Parquet format.
exactly.
Okay.
Yeah. So when we first try to run the command, it's actually failed because, of course, we haven't created the extension yet. So it says the Parquet format is not recognized. After we actually create the extension and try to run the same command, we can see that the rows gets copied into the Parquet file.
Yep. Makes sense.
As you
Yeah.
can see, the employee data.parquet file has been created.
And that is the name of the table is employee data.
The name of the table is employee. The
Just
file,
employee. Yeah.
yeah, the name of the table is just employee. The file name you can
To the
specify.
file name is employee data. Got it. Yeah.
Yeah,
Yeah.
correct.
Makes sense.
Yeah. Now we'll be using the functions that PG Parquet provides to read the metadata of the Parquet file that is created. So this is the file underscore metadata function. It basically tells you the number of rows that are present in the entire Parquet file, and it also tells you the number of row groups that we have. So currently, if you can see, there is only a single row group. Let me go back. Sorry for that. I think we were here. Yeah. So currently, as you can see, there is only a single row group in the Parquet file. So as I mentioned, there is a configuration that you can use to specify the number of rows in each row group. By default, this value is around 1,20,000 something rows. So if you're not using that, only if you have like 2 lakh rows, there would be two row groups created.
Yeah, that's
The same,
200,000 for the American with the rest of the world.
yeah, sorry, yeah. Yeah, so the second function that I've used, that I've tried to show you guys, is basically the parquet.metadata function. We can use this function to get to know about the columns in each of the row groups. Since there is only a single row group, we only see row group ID as 0 for each of these values. But here we can see the column IDs from 0 to 5, which are the 6 columns of the employee table. Can also see the type of each of the columns that we have in the table. Now, the third function that PG Parquet provides is quite interesting, which is the column stats table, column stats function. It basically will show you the minimum and maximum values of each of the column chunk in all the row groups that you have. So as you can see, this will show you. So since again there are only 6 entries because there is a single row group, but it would show you the minimum and maximum values of your column chunk. This actually, as I said in the start, this actually enables the applications to filter out the row groups that they want to visit in the start itself. So it makes accessing and reading a Parquet file really fast. Now, I would also try to import the data back into another table. So I have this employee copy table, which is the same exact schema as the employee table. Currently, there is no data into the employee copy table, right? Now I'll use the copy from command to copy the data from the same Parquet file, which is employee underscore Parquet, into the employee underscore copy table. So yeah, in general, the copy from commands takes a bit more time than the copy to command because there is an added step of matching the schema between the Parquet file and the table. So that step takes a bit more time. Uh, yeah, so it will now try to copy the column based data that we have in your Parquet file into the employee copy table. So it says it has already copied the 10,000 records, and also we can run the count star query to verify that. So as you can see, we do see the 10,000 records inserted into the employee copy table.
Yep. Yeah, that's amazing. Yeah.
I hope I was not too fast. If you guys have
No,
any,
I think it made sense. I think that, yeah, I think 10,000 going all the way to Parquet. So going from Postgres, converting it to Parquet, storing it in S3, and then
yeah,
pulling from S3 in Parquet, converting it to Postgres Yugabyte format, storing it in a Yugabyte table. Yeah, that's
yeah,
amazing. And yeah, I think also this makes sense because like increasingly with a lot of workloads like MLAI especially, you have to pull data from warehouses and mix them with transactional data and build indexes or serve both together. And both the ability to pull and push from there is amazing, and also the ability to scale the database, right? So you're able to operate on it and do more with it. So yeah, it makes total sense. This is amazing.
Cool. Yeah. Uh,
Right. So did you have anything else? Yeah. So when is it available? Yes. So
yeah. So we have already landed the changes into the master branch, and it is expected to be released with the next YugabyteDB release. So watch out, guys. You can try the PG Parquet extension with the next release.
awesome. Fantastic. Fantastic. This is amazing. Is there any other work that you're aware of that's going on the Parquet side? Like anything that the community is doing to improve working with Parquet, etc.?
Uh, Not actually Parquet, but yeah, there is a lot of work going around the PG Parquet extension.
Yeah.
So we had we had chosen a particular Parquet version and moved that into Yugabyte, and we are based out of that. But I think day before yesterday, I saw a new feature that has been added into the PG Parquet extension. So currently, when you're using a copy from command, it only allows you to copy from a single Parquet file. That is the current version that we have. But in the latest release, about I think a few days back, they have uh, added support to copy from multiple Parquet files.
Oh,
So
amazing.
yeah, you can specify like star.parquet from within a directory, and it would copy the data from all those Parquet files into your Postgres table. So that would be a great support, and I think we would also want to have that in our version of it.
Fantastic. Fantastic. Awesome. Thank you. Thanks a lot, Harsh. I think that was really educational. It was really good, and it's also very interesting to see. So can't wait for it to come out for folks to try it out. So, folks, if you have any questions, feel free to post on like the comment box directly in the stream, or you can join our community Slack, like it shows here, yugabyte.com/Slack. And we appreciate you giving us stars, and join us again, right? Same place, same time, for successive sessions. Uh, Thank you, everybody. Thank you, Harsh. Really appreciate it. Thanks for staying up late for making this happen. Thank you.